Hello and welcome, and this is another video about some math that I've been thinking about. This one is actually about cubic functions. So if you have a cubic function, what happens is actually the locations of the max and min are symmetrically distributed uh, with respect to the inflection point. The inflection point's right in the middle between the two for any cubic, unless you have the basic cubic, like just x cubed. That's where those 3 points actually converge to one. Uh, and But in general, that's going to have some shape like this, or it could go the other way, like that. Um, so, anyways, if you look at the calculus of this curve, so if you take the first and the second derivatives of this, you get these here. So just using some basic power rules and sum rules, so forth, to get those. And then if you look at the critical points, so where the first derivative is 0, you don't have to worry about where it's undefined. This is a polynomial, so nicely enough, they're defined everywhere, so you don't have to worry about that strange situation in this case. So you set the first derivative equal to 0. It's a quadratic, so you can use the quadratic formula, which is nice. But the A's and B's, you have to be a little careful. So you see that your A is actually 3A. Oh, this one doesn't work. Let's try this. 3A, and then your B is 2B, and then C is C. Okay, so it's negative B plus or minus square root of B squared minus 4AC all over 2A. So there's that. So when you plug those in and simplify it, really you just got to simplify this. So that's 6A. And inside the square root, you get 4B squared minus 12AC. You can factor out a 4 and then take its square root. So you get a 2 outside the radical. Square root of B squared minus 3AC under that. So you end up with this quadratic formula type of solution. So this gives you the locations of the relative max and min. Okay. And if you look at the second derivative, this will give you the inflection point. It actually changes concavity there. You can see if it's negative, then depending on the values of A and B, that's going to determine whether it's positive or negative. And if it's positive on one side, it's going to be negative on the other, and vice versa. So you'd have to know the signs of both A and B to really determine anything from that. But it does change at negative B over 3A. Okay, but you look back here, that's exactly the value that we have right here, negative B plus or minus some number, negative B over 3A, negative B over 3A. So it tells you that the inflection point is right between those two extreme values. Okay, so I have the kind of the sketch here. So the x location of the inflection point, so the value there, negative b over 3a, is the midpoint of the locations of those relative extrema, so on either side. And again, depending on the signs of, well, a, I guess in this case, these two could be switched. Okay, so if you had a minus here, could actually be on that side, and vice versa, depending on if it goes like this or if it has the other form. Okay, but that's a little bit about that. Another neat symmetry thing, and again, I love these kinds of things with math, and I love sharing about it. So I hope you all enjoyed that, and let me know what you think. And if you have any other ideas, that's a little bit about that. So thank you.